Alrighty, hello, welcome back. Stream number 3 on owncast.eom.dev. If you are watching this at a later date on YouTube, feel free to join us. There will be a link in the description for the live versions of these streams. There's a schedule there as well. And let's jump right into things. Last time I was showing you one of the services that I had deployed. It is Discourse. And I have done a few things on Discourse that I would like to share with you to show you how I am planning to use the platform and try and build a community here. Basically, I want to draw your attention to these two purple posts down here. These are both posts for the previous live streams that I have done. It's pretty similar to what you would find on YouTube in a sense, in that you can watch the video, there is a description, and hopefully in the future there will be replies and discussion. You should be able to log in, I'm in a private window here, using Google and GitHub. LDAP is for myself and people for whom I have created accounts, which is pretty much no one. So you, dear viewer, should be probably using the sign in with Google, maybe GitHub if you prefer. If this does not work, please leave a comment and let me know, but you should be able to sign in with exactly the same account that you are using on YouTube to leave comments right here. One thing that I want to show that's kind of neat about this is the integration that I have with other services that I am running on this network. In the first live stream I did here, I did a bit of a tour of this network, and I showed you MinIO. Which is an object storage service similar to Amazon S3, if you're familiar with that. And the video in this post, if I copy the link and open it in a new tab, it's very small on the screen. I apologize for that. This is a 4K screen that I've just increased the zoom on for you. But the link to the video itself is to MinIO. We can open that and it will bring up the whole video and kind of just start playing, which looks a little bit weird. Hello, little me. How are you? Anyway, yes, so the post, if we look at the actual, I'm not logged in here, so we're not going to look at the actual text, but I just put a link to the MinIO object in the text of this post, and it naturally gets embedded into the video. If you're interested in the technical side here, I can kind of quickly bring up OBS. There's even more mini-me's. This is kind of fun. It's probably bad for my FPS, but OBS itself is going to be saving my videos. I am recording and streaming at the same time. It saves these videos in the MKV format initially, but that does not embed as nicely into these posts. Most web browsers prefer an MP4 format, so after I record them, I convert them using the remuxer that is built into OBS. Just change them over to MP4. That MP4 gets uploaded to MinIO. If we look at the URL, you can see a little bit about the background there. There's a bucket called Broadcast. I have a folder called Live Streams, and then the stream is just the date and time of the stream. So that's how that is organized, and that folder within the bucket is publicly browsable. So you don't necessarily have to go on to Discourse to get directly to that video, but this is so much nicer. So yes, MinIO integrating with Discourse. And I can do that with other data formats or media formats as well. Images, for example. I haven't actually tried this, so I'm not certain that this will work, but I see no reason why it shouldn't. Images should embed and audio should embed, so I will be able to, in the future, publish a variety of media formats onto MinIO and then create discussions about them on Discourse, and that gives us a integrated platform with a lot of different things to do, I guess. Anyway, so as you'll notice, I have created this category for broadcast, and that is mirrored in the bucket name of my MinIO server, broadcast. a little bit superfluous. I think I mentioned this in the past few videos, that I'm using the organizations and teams that are kind of baked into these software applications, even though I'm only one person. Ideally, in the future, that will be more useful, maybe with groups of people, or we'll see what happens. But I'm kind of just using it at the moment because it's how the software applications are organized, and I want to be consistent in my organization. So I created a broadcast organization in PHP LDAP admin. Do I want to show that? Not. Okay, I guess I kind of need to now that I've mentioned it. I'll need to pull it up in another window. Again, this is referencing back to the first live stream that I did where I was showing off the platform. This is OpenLDAP. This is the single sign-on server that that my network is using. So I define all of my users and organizations and such here. And as we can see, the organizations are defined here. DevOps contains the software infrastructure that deploys this whole network. Finance would include, say, the Kraken bot, and broadcast is covering these live streams. Like I've said, a bit superfluous to be organizing things like this for one person, but I am accepting the schema that the software is providing me, and I am simply being consistent in its application. So what I have done is on Discourse, I have created a category for that organization, and I would probably create them for others, but I'm just doing it for this one thing at a time. So I've created this category for broadcast, the broadcast organization, and what we can see here is federation. So this is connected to ActivityPub. ActivityPub is a federated platform for, if you're familiar with Mastodon, that is using ActivityPub in the background. And so if you have a Mastodon account or an account on one of the other ActivityPub applications, then you should be able to follow this address right here, and we'll be getting updates on any posts that go into the broadcast category. Additionally, if you would like to be more specific, you can look at just the live stream tag. So all of these live stream posts go into the broadcast category and get this live stream tag. And the live stream tag also has a federated actor. It's a bit interesting the way ActivityPub works on Discourse. You essentially create a discrete account for every single category or a tag that you want people to be able to follow. I believe that users also have an ActivityPub profile on Discourse. So like my user, which, let's see if we can, there I am. Hello, mini-me. That kind of looks weird and grainy on my screen, at least, that image. I don't know. Anyway, so I should be able to follow like Eric at discourse.eom.dev on Mastodon or another federated service, but I don't see the link for where that is at the moment, and I don't really want to spend a ton of time on that. So we're going to move on. In the future for Discourse here, this is kind of the central hub for whatever community we end up building here, hopefully. And in the future, I will probably want to put ads on this. There is a, I can't just open that. There is a plugin for Discourse that natively allows ads to be integrated onto the site using Google AdSense. My YouTube channel is already monetized, so it's already using Google AdSense there, and so essentially what that does for me is make it so that there is no loss in me putting these videos up again for free on MinIO. You see, if I were to embed YouTube videos in these posts, then the ads could roll again, and et cetera, et cetera. And by using MinIO, I am not getting the ad revenue that I would from YouTube on this site. but I can replace that by just integrating Google AdSense into it myself. Additionally, there is a subscription plugin, and this allows users to sign up for a subscription. This is kind of like Patreon, so like, I don't know, a $5 a month, $10 a month membership, something like that, and turns off the ads. I like the Google AdSense thing. Of course, I like it. I'm not sure how much you guys are going to like it, but I like it. The memberships, at least here, built into Discourse, I like the idea, but I'm not sure I like this as the implementation. So if we go into the documentation here, which is somewhere, what we'll find is that this integration or plugin is only going to add a user to a group. So once someone signs up for a membership, all it does is add them to a Discourse group of users. And given that I have my OpenLDAP server, which I have closed and will not be pulling back up because it will be tedious, given that I am managing users in this OpenLDAP server and I have a number of different services that I am running, and I might want to offer members benefits that are outside of Discourse, I'm thinking that it may be worthwhile to potentially build a bespoke application for this. For doing so, we would probably look at something like Medusa. I'm going to take a timestamp here. 12:04. Continuing on with taking notes for these live streams so that it's easy to post a description later. I also created a to-do list of a lot of the topics that I want to discuss, so this is feeling quite a bit smoother than the last one. Preparedness, folks. That's what it's all about. Not really. Anyway, so Medusa. Medusa is the world's most flexible commerce platform, or so they say. If you're familiar with Shopify, this should be familiar. Not that I would really know that. That's just something I read. I have kind of just started looking into Medusa, even though I have heard of it before. This has some pretty easy, if we go to the developer documentation, we're losing the zoom. Okay, so this is a little bit more do-it-yourself. As you can see here, there would be coding involved if I were to use Medusa. But they make it a little bit easier in that they have all these modules. So like a payments module, a cart module, a customer module. They have built-in integration with Stripe, which is the same thing that Discourse would be using for these memberships. And they also have where is it? Subscriptions. Implement a subscription-based commerce store. So this essentially offers the same thing, but will be a little bit more do-it-yourself. And I should be clear about the same thing as what? The same thing as Discourse subscriptions. So this is going to be a lot easier to just plug and play into Discourse, but this is going to be a lot more powerful and a lot more flexible, so that if I have someone sign up for a membership on Medusa and I deploy a service that has nothing to do with Discourse, just something else entirely, but I still want my members to have some benefit or gold sticker or whatever, Medusa will be a lot more flexible in allowing me to do that. Also, offering discounts to customers if I were to open up a store for a physical product, and I wanted to offer members a discount. That's going to be easier to do with Medusa because I can put the store and the membership together, which is not something I can do with this basic module. That being said, I've only really just started looking at the documentation here and thinking about the potential. In the future, This could be used to build something quite substantial. Say we take our matrix chat, you could do a pay per message service, setting up an API where users would connect to the API to send a message across the Matrix platform. This would not be a actual business because Matrix is free, so why would you do that? But hypothetically, I could charge people per message using something like Medusa because it's flexible and extensible. So, but it will require a lot of coding and do it yourself. And at this stage, I don't think that is going to be totally necessary for me at the moment. So I'm just thinking about the future. You may, in short order, see advertisements show up on this Discourse instance. Memberships will probably not be here for quite a while. We'll see. Anyway, I think that wraps up what I wanted to share there. And next, oh, I don't have this open. That's kind of okay, a little bit annoying, but I have been working on a separate thing. I'm going to open LibreOffice. So these live streams are a bit casual and quick. I'd kind of turn on the camera and start talking about what I have been up to, and largely based on some of the comments that were in the first video, I have started to think that it would be useful to have more written documentation alongside this. So I have begun working on a paper that should hopefully serve that need. At the same time, I can show you how I use Nextcloud in some of my daily workflow. Let me take another timestamp here. Okay, so what you're looking at here is LibreOffice Writer. This is kind of the open source version of Microsoft Word, if of course you're familiar with that. But what's interesting about this is that I also have an instance of Nextcloud deployed. I'm not going to be able to log in on this because it's a private window, but I can show it to you. Nextcloud is a file server and groupware server, and alongside it, I have deployed an instance of Collabora, which allows for document editing. So essentially, I have a LibreOffice Writer server integrated into Nextcloud. Now this is my local client, my local LibreOffice Writer client. And what I do is I can open remote. It can take a second or might be somewhere else. There it is. It asks me to log in. And this can be a bit slow. So this is kind of the main downside of this is the speed. But here we can see all of my documents that are saved on Nextcloud. You're not going to find anything particularly fascinating here, so don't get too excited. But yes, as you can see, it's quite slow. This computer is especially slow because it's using a Wi-Fi connection and is on the local network. If I were a remote user, this is actually a bit faster. But anyway, I effectively can work on this remote document on my local client using LibreOffice and Nextcloud. And I'll just pull up the document and show you the outline of it so you can kind of see what I am working on. At the moment, I have not created any public way for this to be viewed. It's very skeletal at the moment. In the future, I will probably post a link on Discourse where you will be able to read a rough draft and potentially give me some feedback on it. Boy, this is slow. Not doing a great job advertising itself as like, hey, you should use this too. Even while I'm writing the document, it can kind of freeze up and we'll need to reconnect. There we go. But yes, here's the document. Let me make it a lot bigger for you. let's just take a quick look at the table of contents. Basically, I just want to outline what the project is, like the physical things that I have used to put this together. I want to tell you what software is running on it, how it is configured, the services that run on top of that. I'm thinking about running some performance tests on this. I may have to deploy some, dummy websites and, go to a remote location to run some tests, but would like to put that in as part of this paper, and then talking about the utility of it, what I am trying to actually do with the network. And that's really all I have at the moment, is just a bunch of headlines. Hopefully this should be a little bit more searchable, and yeah, I'm not really sure. I may never even finish this. We'll see. The idea is basically just to have a written version of what I'm showing you here, a written, formalized, and clear version of what I am showing you on a more casual basis here in these live streams. But that's a very long process and something I'm just kind of working on slowly in the background. It's pretty cool when you start using the templates and like the styles here, because you can output this in a lot of different formats. So I can take this document, it's in, what is it, ODT format, open document text, and I can export this obviously as a PDF, but also as HTML or LaTeX if you're familiar with academic writing. But yeah, by using the built-in headings and bibliography and date variables, etc., just kind of nice that it can output in all these different formats. Anyway, okay. The Kraken bot. As we ended last stream, I showed you a bit of this project that I had in the works for quite a while, actually, and put aside while I was working on this platform. I'll just, while I'm here, let me go ahead and just show you that Gitea as well, Gitea.eom.dev. You can also sign in with Google and sign in with GitHub. Same deal applies here. You should be able to use those accounts to create posts and issues, etc. I'm going to take a sip of water. I went for the frozen water again, so it's not very refreshing. Anyway, so let's pull up the project, and I kind of do like looking at this colorful board. So what I have been working on this week are these two issues, the top and bottom, and those are encapsulated in this pull request. I'm not so wild about having issues and pull requests on the same board, especially because all three of these are referencing kind of the same thing. So I don't know about that, but anyway, what we are going for here is to basically get the algorithm that I previously had functioning correctly back to a correct functioning state, and then also to implement monitoring using our matrix server, the same one that I'm using for chat. Anyway, work in progress. I've run into a bit of a roadblock here. So let's just pull up some of the code, and I'm going to switch to my branch. And actually, let's just go ahead and refresh on pretty much all of this Kraken bot. Let's just walk through the whole thing. I actually made a mistake in what I was telling you last time. So just for the abundance of clarity, let's start at the top in app.py. All that this app.py does is load our environment variables from a .env file and then instantiate our Kraken bot. And if this is the main application, then it updates and executes the bot. So remember that this is intended to run in a Docker container as a one-shot execution, running Kubernetes on a cron job. So when it runs in that environment, it will be main, and so it will execute. But when I'm testing things, it can be useful to import this file and be able to play with the bot without having it actually update and execute. So this is a nice little feature. But basically, we are taking our bot and we are going to be giving it a model and a trading strategy. So let's take a look at those things. Our model is going to give us a model of the market. I probably should show you this market as well, even though I did last time. Product Kraken. There we go. So this is a cryptocurrency exchange market called Kraken. It allows you to buy and sell cryptocurrencies using an API. Probably better if I show you the logged in version. Let me pull that up. This is my portfolio, which is pretty abysmal. We want to look at, let's pick the top one. So this is a cryptocurrency exchange. What we are looking at here is MiUSD exchange rate. And this website has an API that is going to allow me to use Python code to execute trades based on the market data. So I can collect market data, I can process that data, and then I can act upon that data using Python scripts. And that's exactly what we're doing with this Kraken bot. So our model, what this does is we are going to go to that Kraken API and collect our data, get the data on all of these different exchanges that we can make trades on, and it is going to process them in some way. This is an abstract class, so that's kind of an abstract description, but that's basically what it does. We are going to create a model of the market, and then we are, based on that model, going to execute a trading strategy. This trading strategy basically just tells us, based on that analysis, create some orders, either to sell existing assets or to buy new assets. Okay. The strategies that we have implemented are a linear regression model, and what I showed you last time was this high-low cutoff.py, but actually MyStrategy.py is the one that I want to show you. Linear regression, I don't want to go too much into this. It's actually, I'm not performing the linear regression myself. It just uses SciPy stats and performs an actual, let's see. LinRegress. It just takes the pandas data frame that Kraken is going to send us in the API call and creates a linear regression out of the data. We're not going to go too much into it. It is going to filter them based on R value, and R value is going to tell us how well our data fits the model. So probably be better if I were to open some code and show these things, but essentially, I'm not sure I'm even going through this in the clearest possible way. Yeah. Let's back up a step. Apologize for that. The bot, the Kraken bot. This is what's interfacing with the actual Kraken API. Kraken publishes this Kraken X library, and all I'm doing is extending it. And all of these functions just take the built-in Kraken functions of tradable asset pairs, account balance, trade balance, etc. And it just adds a little bit of extra functionality to log what's happening, and sleep in between each API call so that we don't hit a rate limit. For the most part, this is just implementing that logic around the basic Kraken API methods. But what's kind of important are the update and execute methods. There's some update stuff that happens. We're going to get a list of all of the tradable asset pairs from the Kraken exchange. We're going to filter those asset pairs for all of the ones that are based on the United States dollar, because I want to be increasing my United States dollar value, not necessarily some weird made-up coin. So we can also apply like other things, like we want a certain volume of trades to be occurring on a market. Essentially what I'm doing here is just filtering it by whatever parameters I wish. We're going to update our account balance. We don't really need to worry about what these things are doing. What's interesting are the model.update and the trading strategy.update. So after we have hit the API and collected all of our data, filtered all of the things we want, we are going to create a model of that data, and then we are going to impose our trading strategy upon that data. Okay, so at this point, this is where I should have shown our linear regression model. So what's happening is for every single market that we look at on the Kraken exchange, did I close it? I did. So that USD, for instance, we are going to create a linear regression to show us how that value has changed over time. And we are going to order these. First, we're going to kick out any of the ones whose R value indicates that they are not actually linear regressions. So if the data does not match a linear regression, we don't want to bet on that one. It does not fit our model. The remaining ones get sorted based on slope. So whichever one is increasing the fastest is going to be at the top of the list. And then our strategy for trading is quite simple. This MyStrategy. It is going to first sell any assets that are no longer the fastest growing, that are no longer in our list of top performers. And then until we have the same number of investments that we had at the beginning, we are going to make new investments. So basically, we're going to replace any of the ones that we have sold. And we're just going to start at the top of our list of assets that have gone through our model and work our way down. So the best performer is the first one we're going to buy. The next best performer is the next one we're going to buy. Okay, so this isn't, again, a wildly complex or even good strategy. It's probably going to lose money. It has so far. So that's not really the point. The point is more to get this network working together and to show how something like this can work with all of the services that I have deployed so far. We can kind of already see that working because it's here on Gitea. This is my Gitea instance, and this is the code for my project. So already working like that, but what's going to be more interesting is once I start getting it working with Matrix, which is what the actual objective of those tickets I was showing earlier is. Unfortunately, that did not work. Let's find out why. So I'm using something called the Matrix.MinIO library. Let's pull that up. I believe I pulled up the client and server page for Matrix on matrix.org. They also have SDKs. This is one of the Python SDKs for Matrix. And let's take a look at the example. We can see why it did not work in my application almost right away. Async.io. This is using asynchronous programming. And so we do asynchronous functions, and then we await the result of our methods. So this is how it is supposed to work. This is how this is how they say it should work. And I tried to do that over here. What I wanted to do was to create a basic Python logger that would log the messages into a matrix chat. And you can see here I have the logger defined, and all it really does that's special is add this matrix handler. The matrix handler is what implements NIO unsuccessfully again. The problem, first of all, I did not make these asynchronous functions. When you do make this an asynchronous function, we get an error. So init for this handler is, or init for any class, is supposed to return, well, what was it saying? I can pull up the actual error in this other window, I think. This is a bit small. This is my active environment working on this project, and here is a previous execution where I did put await and async definition in the initializer for the matrix handler. And what we see is that init should be returning none, but is returning a coroutine, this await coroutine. So my design for this is basically entirely flawed. I won't be able to log into my client using a logging handler. So that's unfortunate. The work I have done on this week will be no good. And I'm not exactly sure what to do about it. Ideally, if we look back at the example here, we get this asyncio.run main. I am hoping there may be a clever way for me to maybe create a matrix class outside of this that runs separately, and maybe this posts to that somehow, or maybe it could be as simple as in the app.py and this async.io, yeah, right here, getting this async.io run, that could possibly help. But if we actually try this, which is the version that's running, yeah, we get that. So long and the short of it is, the bot works, the model works, and the trading strategy works, but my matrix logger works. And that's kind of the big point of this, is getting it to post what it's doing into a matrix chat. So I have more work to do on that, and will probably be continuing to work on that in the upcoming week. I was hoping that I would be able to actually show you that working, but unfortunately it's not. So we may have to end this on a bit of a sad note because, you know, it's not working yet, but that's okay. I am going to continue working on this over the next week. I'll be redesigning this matrix logger and matrix handler. Actually, I'll show you. Yeah, I did try to use this HTTP client. They don't have an example of this, but in addition to the asynchronous client, there's an HTTP client. And I thought that maybe this one was not asynchronous, and I could just instantiate an HTTP client and use non-asynchronous methods. But when I tried to actually log in and connect, it would fail. And if I created the login in, sorry, I'm trying to like move around files at the same time here. Yeah, if I created the HTTP login in the instantiation, then when we go to this emit, which is what's going to post the message, it would say that I was not logged in. And if I moved the login down here, then it wasn't connecting. And yeah, so anyway, this matrix logger needs a redesign, and it occurs to me that it may be useful to have this as a separate library so that I could put it in other projects as well. But the long and the short of it is I'm going to continue working on this over the next week, and we'll be posting an update on that next week. With that, I think that I've covered everything that I wanted to show, and I will just point out again that this live stream will be uploaded to MinIO, and I will put a post about it on Discourse. I would be absolutely delighted if someone would like to try and log into Discourse and leave a comment on that video, but you know, no obligations. Anyway, I think that'll be all for today. Thank you for joining me, and I will see you next time. Toodaloo.